So moral of the story, it's very hard to have long hair and wear a microphone. So hi, fun fact, just to kick things off. As you can probably tell from the title, this will be a somewhat Harry Potter inspired kind of talk. While I've seen the movies more times than I'm like willingly to publicly admit, I have yet to read the books. So yesterday, I went and I purchased my first copy of the books. And today we're in the zoo, so the child in me is like very happy right now. So hi everyone, welcome to this, what's going to probably be like a magic class course, in which we're going to talk about something very serious, which is security, in a bit of an unserious way. My name is Ingrid, and you can find me on GitHub and Twitter and a bunch of other places as Ingrid E. Come nerd out with me if you're like passionate about security or culture and tech in general. Do reach out and let's talk about it. A little bit of a story, though, to kick things off. So I work for a company called Intercom in Dublin, and we are a Ember front-end, Rails back-end, 4 years old app. And if you look at our stats, just for the last month, we've had an average, for the front-end application, we've had an average of 51 authors that committed almost 700 times to, in total, to all branches, about 550 times to master, which resulted in almost like 1,000 file changes with 20-something K additions and about 7,000 deletions. And on top of that, we always say that shipping is at the heartbeat of Intercom, so we're shipping to production more than 100 times a day. And this is to just give you like a little bit of perspective into like the examples that I'm going to talk about today and why we think they're relevant and the amount of weirdness that we have to deal with. So one of our main components is a real-time editor that enables our customers to create messages for their customers. And a big part of that is allowing those messages to be personalized, which means we allow for HTML input. As with everything that contains HTML, data sanitization is required. So say if you're looking in particular at something that has a source, or a reference to like some sort of URL, then you'd probably look at the current element.source or the current element.href. And if they contain a value, then you want to encode that URL and return it. And I think the light is not helping right now. I just realized that. Ooh, it got darker. So you want to encode that URL and return it. And that works, right? Well, turns out browsers are awesome. And they've come a long way in the last couple of years, but they're also really weird, like really, really weird. And what I mean by that is that, well, what if I told you that href can sometimes return as undefined, even if it's present in the file? And if your reaction right now is like, wait, what the are you even talking about? That's exactly like the way we reacted when we discovered this in November. How can this happen? Well, let's say you have a link that's wrapped inside something that's a malformed math tag. So you have math and then a link that contains a reference to, let's say, something JavaScript. And you have, like, you're closing the math tag, and outside of that, you create another link that has a reference to something. Well, if you go to the console, and you're going to ask the browser, hey, browser, what's the href value of the first link? Well, the browser is going to get a little confused and go, well, I don't know what you're talking about because I don't see a value there. It's undefined. And then if you're doing the same link to that href, the browser is going to go, oh, OK, this I know, so there you go. And that's a problem because, well, remember the script that sanitizes data? Well, the first link, which is actually one that I do care about being escapes that encoding and gets returned as it is, which results in something that's called a stored XSS vulnerability, or like cross-site scripting vulnerability. And while there's different ways to block that, there's also something to keep the user experience to keep in mind. And like furthermore, like browsers actually refuse, like have different opinions about how they should even display the first link. So for example, Chrome displays something like a broken link. It's just like a blob of text. Safari is like, I don't even know what you want from me, so like it just ignores it completely. And like Firefox attempts to at least display the text, but fails miserably at like everything else. And turns out that like a sane way to like fix this is just use so like a get attribute rather than doing just like a href. A problem with that is when that script goes beyond it being just an alert, and it goes to being something like document.cookie. So say you have a something-evil.com that's trying to capture your cookies. Without that URL skipping sanitization could result in something like something-evil.com plus document cookie. And this will actually execute. And the reason why that executes is because of something called a same origin policy, which is a very important concept on the web. And what that means is that the script has access to all the user data as long as that script runs under the same origin as the current website. So say that I'm on ingrid.com, script inside the malform math tag will have access to all the cookies that are under ingrid.com. And while, again, something like this can be blocked by a content security policy, it's not great to have. And again, get attribute is apparently the unanimous way in which browsers agree to look at href inside the malform tag. But it kind of goes, there's something with animations today. There's also a GitHub repo where I publish some of the weird things that I'm eternally curious about. So if you want to try this on your own, it's just plain HTML. Do check it out and give me feedback and ideas, or if you find any other weird stuff, feel free to contribute. And it kind of goes to my point that you should know your enemy. And we've been talking, when we're talking about security, we've been talking about user input for a very long time. But turns out that users are not always your enemy. Your a browser is just an app, so it has issues and vulnerabilities too. So it's not always just the users. Well, cool, that happened. What can you do about it? How do you prepare for battle and make these things less evil? Well, ideally, you should write your code in a way that deals with weirdness better. And you should be able to have something that would be able to detect and alert on such weirdness. And wouldn't it be nice if you'd also have something that would auto-magically block things from happening and just make the world safe again? So that's what we're going to try and talk about today. And if you look at your code, well, the code is a very vague concept. How should you even start? If you look at a very, breaking it down even further, if you look at a very simplified version of your application, you have something that is in charge with displaying your content, which is HTML, and depending on which framework you're going to use, you may or may not have templates as well. And then if you look on the logic side, the computation that needs to happen for all that data to be displayed, you have JavaScript, and that's where your controllers and your components live. And we're going to look at all those areas independently and try to determine what you can do to make things better. Something very important before you even start looking into security vulnerabilities is understanding how your framework thinks about HTML and interacts with HTML. So what is it about HTML? Well, it turns out that different frameworks have different ideas about what HTML means. So something like Ember, which we use a lot, the rendering engine of Ember escapes HTML by default in an attempt to prevent XSS vulnerabilities. And if you look at something like React, it's a little different in a way that it forces you to actually return an object that says this is HTML that I know is okay to display, just to attract your attention that this is something that you need to care about and be deliberate about. And again, they're doing these things, as different as they are, with the same idea that avoiding default behavior to introduce an XSS vulnerability. So what does that look like code-wise? And I'm hoping you can see it. Well, in Ember, say I want to write a helper that returns a cat image, because cats are cute, right? Well, I'm just using a cat API and returning an image source. And then Ember uses templates. So in my template, I'm calling my helper and say, give me a cat. Well, Ember's going to look at this and it's going to go, I don't think you want to do what you think you want to do or understand what you want to do. So just to be sure, I'm going to go and escape this for you. So instead of an image of a cat, which is expected, we see this blob of text, which is the image source, and the URL to what I was hoping it would be a cat. And if I really want to display the cat, I have to tell Ember that this HTML is safe, so I'm going to vouch for it and say, hey, HTML, wrap the entire thing in HTML safe and return it. And then Ember is going to look at it and go, oh, you meant the cat. So it's going to show you the image of a cat reading military strategy, which is me right now, and what we're doing here today. There's also like a guest if you use Ember or you're curious about Ember. It's very easy to like understand. You can go and like play around with it. Because we mentioned React, let's look at how React does this. Well, say I want to do the same thing. I have a function that is trying to return a cat, and I'm returning the image tag with the source of a cat. And then React, HTML safe and React landed something called dangerously set in our HTML, and they use the word dangerous because they're trying to like attract your attention that this is bad behavior and you shouldn't use it. And even if you're just doing that, React is going to look at it and say, nope, I don't know what you're talking about. This is not the solution you're looking for. And it will do nothing. It will, your browser console is going to display an error, but on like the page, you won't see anything. And if you want to actually get the image of the cat, you have to return an object that says HTML, the value, and then, which is like the cat. And when React sees that particular object in that format being returned, it's going to go, oh, OK, so you're saying this is safe. I mean, fine, I'll return it. It shows you a cat that's kind of confused of like, human, too many rules. What are you even doing to me? And, well, what the cat and me are trying to say here is that you should avoid having to decide if HTML is safe. It's kind of like trying to decide if it's safe to drink a cup of coffee while there's someone behind you that may or may not scare you to death. Constantly, every moment of your life. It's no way to live or like drink coffee. So again, when I say HTML safe, every framework has an equivalent. It's HTML safe in Ember, dangerously set in our HTML and React. Angular has a version, Vue has a version. If your framework doesn't have something like that, you should ask yourself some questions. So now that we know a little bit about what HTML means in terms of the framework, let's look at JavaScript. And we all kind of want to write good components, and we want to have other humans, ideally on other teams and outside of our teams, use those components, because reusable code is awesome, and we're strong advocates for that. A very common pattern that a lot of people are talking about, especially when it comes to like hacking HTML at the component level and like using that rather than choosing a different way to like interact with HTML, is that you have components that their arguments are the de facto public API. So there's no other way for you to like go around that. You always have to use those arguments, which force you to go into like these hacks of like, this HTML is safe and this is okay and I'm making assumptions. And the 90-something% of the time, the root cause of that is that your component does too much. It's too big, it has way too many like strict rules, and everyone is forced to think about that component in only one way. And a good way to, let's first look at an example. So say you have a card component that just displays the title and displays a body. And in about 3 months from now, because products evolved and we want to move fast, you want to display something else instead of just a simple title. You want to have a name and say like, hey, my name, and then have a text, like a body or a description or whatever you want to display there. Well, a very good way to iterate from like the first version to the second version would be to say, well, sure, I'm just going to say that hi name, and name will be displayed in bold, and I'm going to return that, and that's cool. Like, that's all I need to do, just hacking it together. But we've already kind of looked at that. You don't know what's in the name, and then you're going to try to escape it, and then it's going to fail because reasons, and that's not really like a good way to do it. So a better way to look at components that would make you avoid being in that situation would be to break it down into like smaller components that do one thing and do it well. Just do one thing, be lazy, do your thing, you're done. So in the case of the card component, well, if we look at it, it has a title, and there's no reason why that title can't be a component on its own that knows how to display different things depending on how the component gets implemented. And then you have a body component, and then the body can worry about how to display itself and what kind of content it has, and way more flexibility on when you're actually implementing that component. And then they're all wrapped in this supercard component that has a very simple API that it will never change, and you don't have to like worry too much about like using it for like different purposes in your app. And then the title and the body can change as much as they want, but they're not going to impact where that card is being used. So the idea is to look at composition instead of inheritance. So has a instead of like I'm inheriting from my parent and that can never change. And that it allows for like better encapsulation and clarity. There's less confusion and more consistency on your code, which is when you're part of a company that has 5 teams working on the same code base, you really want consistency because otherwise you're going to drive yourself crazy. And then each component should decide on its implementation, but how that component gets invoked and implemented in different situations should stay the same. And that's what would make the world a better place and happier. There's a really good blog post about this, so if you're using React, which I kind of notice is very popular here, there's a really good blog post about Facebook called Composition versus Inheritance, where they're advocating for this exact reason, it's for this exact idea, and it's kind of a talk on its own, so I'm not going to go into like too much implementation details, but I strongly suggest you go and read that. And if, again, you're curious about Ember or want to know more about it, they use something called contextual components, that it's the same idea that I've just explained, just different names because everyone wants to be original. But components are not enough. Sometimes you need helpers for stuff like cats or sending emails or returning dates. And when using a helper, a good way to like stay out of trouble is to prefer updating the DOM over returning HTML. And let's look at an example. So say I want to send an email. A safe and relatively easy way to do that using the DOM would be to use the DOM to create the element and then set the attributes. So for example, the href or like the target blank or whatever else I want to include in there. And then create a text node for my element. And then append that text node as a child to the anchor tag. And what that does is that it takes the complexity out of having to decide how you should escape that outside of your app and into the browser. And turns out browsers are really good at handling text nodes, and they're really good at handling escaping and encoding when you're specifically telling it that it's a text node. So it avoids you having to like do magic in your app and leave the hard work and the heavy lifting on how to escape that to the browsers. So it's a very much easier, much cleaner way of doing this than juggling around trying to decide what's actually an email. So as I said, returning the node, yay, everyone's happy. So much cleaner, so much nicer. For those of you that use a framework that uses HTML a lot, and I especially have templates in mind, and Ember and Vue are examples of that. But even in HTML in general, something weird that has been around forever, and it's, for example, Instagram only decided to fix last year after a blogger went ranging that why won't you fix this, is that you should always use no opener and no referrer with target blank. So what happens when you have target blank, which is pretty much I want to open this in a new tab, a very simple definition of it, is that it gives the linking page access to window.opener. And window.opener has something called location that is pretty much a fair game. So when you're opening in a new tab, because it would be a different origin, some of the access will be limited by the same origin policy. But turns out that window opener location is fair game. So the linking page can open that link to whatever the hell they want to do, and it can actually be a phishing website. They have total control over what that page can do. And a very weird thing is that Firefox only decided to fix this bug. So Firefox only used no referrer up until version 52, and Chrome used both. Chrome used no opener and Firefox used no referrer, and they've only decided now to fix it and implement both in version 52, which was released at the end of March. And we kind of we all know that you can't really rely on your users to upgrade or have any sort of decency about like browser versions. So the only way to address this vulnerability is by just adding a very simple reference, no opener, no refer, every time you're trying to open a link in a new tab. And it's a really good way to protect your users. So again, if you're trying to open something, have target blank, I'm obeyed, I seem secure, it has control to like change the location of the page to whatever they want. But if you add no opener, no refer, it will prevent them from doing so. If we're dealing with templates, so templates are like an even weirder land. There's the equivalent of HTML safe for mustache templates, which is called triple curlies. And triple curlies will do exactly that. It would allow you to embed HTML, because like God knows why, but it allows you to do that. So it's the equivalent of like you can use like direct user input and like style it however you want and return that in your template. That's very dangerous because again, user input can never be trusted and sanitization is prone to failures. But the idea is that even if it's possible, you should never actually have to like make that decision, especially at the template level, which is like very like volatile, and you shouldn't have like it should be in charge of only one thing, which is displaying your data. So good helpers and good components should help avoid that situation, and you should never find yourself in a situation where you have to decide what to do at the template. If you do, then you need to move that to JavaScript and like to your components. So now that we know a little bit about how our code can be better, wouldn't it be nice to have some sort of tools that would allow us to do a better job and be faster and alert me if I'm doing something that I probably shouldn't be doing, because there's always going to be things that you don't know. So we want our tools to detect and alert when such weirdness occurs in the code. And there's different ways in which you can do that. You can use static analyzers. ESLint is a very good example. It's a pretty popular linter that allows you to like set your own rules. We're going to talk about that in a second. And I also want to tell you about why regular expressions are evil, and while being able to set like some sort of watermarks on your code to look for a particular behavior is a really, really sane way in which engineers can get more visibility on the state of their code. So when we're talking about like static analyzers, you can actually write your own. And turns out all the static analyzers available out there rely on something called the abstract syntax tree. So all your code, regardless of it being like a template or a JavaScript file, gets displayed as a tree where every function or every method means something. So if we look at what we've talked about earlier about templates, templates or like mustache templates are the equivalent of that for a static analyzer would be a mustache statement, which is a weird name, but it's what they're called. So say you want to write a parser that detects target blank, no opener, no refer, and makes sure that you always have no opener and no refer. Well, you can do that by checking like the element node and the element value. So if the element node is target blank, then do you have an element called ref that has a value no opener and no refer? And wouldn't it be nice if you can plug it in with your CLI, and the idea would be that when something runs, when your file compiles, you build, it will just display a message that would let you know if your code contains like if your code contains like any files that don't implement that, is the best way I can describe it. It's going to make sense in a second. So there's actually like a really good example of an add-on that does a really good job for templates. Is something called Ember Template Lint that's created by Robert Jackson, and it's been created to like plug in with Ember, but the code is can be used as a reference for like any other frameworks that rely on templates. So if that's your case, then I strongly recommend you go and have a look at that. So a little bit of a story time on the idea that we want engineers to have feedback on a very early stage. Before ESLint, in our case, there was grep. Grep is very fast and very effective. So we thought about it in, let's plug it in with our CLI, so have something like a post-build hook. After you build, you get some feedback. And it's either good feedback or it's going to make you cry and be very sad. And we used find and grep and a regular expression plus WC to get the count, and then compare the count against a predefined static limit on our code, and then fail the build if the numbers don't match. And it's a very simple idea, and it worked for a very long time, except that, well, regular expressions are like black magic. And I like ranting about this because I like the idea of your code being maintainable, and I like the idea of if someone new onboards on the code and starts working on that code base, that they should be able to pick it up. And Chris made a really good point this morning that we should be able to welcome people from different backgrounds and different experiences, and it should be easy for them to like pick things up. And regular expressions are anything but that. So here comes ESLint. The nice thing about ESLint is that you can actually create your own rules. So say I'm Ember, so I don't want to see HTML safe. You might be React, you don't want to see dangerously set in or HTML. Well, I can just tell ESLint to, I can create a rule with ESLint that gets used inside the plugin that checks for those blacklisted methods at build time. So building a rule is very simple. It relies on the AST, where I'm checking if, so a function would be like a callback expression, and then I'm parsing through each method on that particular file. If the name of it matches whatever it is that I'm looking for that's supposed to be blacklisted, I'm incrementing a count. And then ESLint also has a CLI and an API that allows you to get access to like the report and like all the logic and all the computational power behind it. So what we ended up doing is using the CLI plus the custom rule to get the issue count instead of using grep. And then integrate that with the Ember CLI. So Ember CLI is the thing that has the hooks that when it builds, it's gonna like give you a report on how performant it was and how you're doing and all that. And then fail to build if the current error count in the report is larger than the number of like predefined accepted for now errors that we have in the code. And also, linters are notoriously slow, and a really good advantage of ESLint is that you can enable caching in dev to have increased performance. So it looks something like this, which I'm not sure if you can see because light, but you run Ember serve, which will trigger build, and then it will go through each file, and then if in any of the files you have HTML safe, for example, it's going to display this red warning saying, hey, you might introduce an XSS, and here's how you should fix it. So something that I've been working on in the last while is to convert this into an add-on that can be used on open source, so stay tuned, it's coming. It's going to be available by July, which is very exciting. Again, that's all good and nice, but it would also be very, very nice to have something that would like automatically block bad behavior and make sure the world is safe again. And that's exactly what the content security policy does. And the content security policy was first implemented, I think, in 2004 as content restrictions by Firefox. Yay, Firefox, I'm a fan. And it's used to tell the browsers which scripts are okay to execute and which scripts should be blocked. And this is, again, kind of like a talk on its own, so I'm going to go through it quickly. But the TLA didn't read on this is that it gets returned as a header, and then in the header you specify which scripts are okay to load and which not. So for example, I want to, in this particular case, I want to load everything that's self, and I want to load everything that's static.mysite.com. So if somehow on my page I have a script that has a source pureeval.com, then the browser is going to look at it and look at my content security policy and go, well, this doesn't match, so I'm going to go and block it. And that was like what version 1 was all about. Because we've evolved and the web evolved, we now have also embedded scripts, which if you probably remember my first story. So the idea is that with version 2 and version 4, you can actually specify the hash source of your, or like have more control of the what's allowed to execute as an embedded script and whatnot. And a really good resource, because again, this is kind of like a thing on its own, is contentsecuritypolicy.com, and they have tons of resources that you can look into. So just a quick recap. The content security policy is a good way to block behavior that you don't want and kind of restrict the pool of things that are allowed to magically run on your page. And then writing clean code helps you deal with weirdness a little better. And writing code with security in mind helps you restrict the number of weird behavior, potential weird behavior that could happen. And it's always good to have tools that allow you to make informed decisions and keep shipping code fast. So thank you very much. That was it.